Good morning students. So myself Akshay Mahendrakar, and from past 2 or 3 lecturers surface tension concept is going on, correct, no? So how to explain, okay, surface tension on the basis of molecular theory. Clear? So by considering the molecular theory, we are going to discuss what? How to explain surface tension. Clear? So for this, what we are going to consider is, we are going to consider a vessel, and in this vessel fluid is present like this. So, 3 sphere of influences we are assuming. Okay, 1, second one, third one. Clear? So what is basically a sphere of influence? In our last class I had informed you. Sphere of influence, it is basically, as the name suggests, it is a sphere, correct, no? And what is the extra thing what we had discussed? A radius of that sphere is equal to what? Molecular range. Clear? So sphere of influence, basically it is a sphere whose radius is equal to what? Molecular range. Now, this molecule, it is present inside the liquid completely, it is completely inside the liquid. So this molecule is get attracted here also, that means neighboring molecule which is present over here, that molecule will attract to this molecule. Let us give some names for this sphere of influences: A, B and C. And here also one more molecule will be attracting this molecule. So here also one more molecule, here also one more molecule, correct? Here also one molecule, here also one molecule, okay? So this molecule A is get attracted by all the sides. Are you getting? From all the sides, this molecule A, it is getting attracted. Okay, this complete sphere of influence, what we are going to tell, A is nothing but this molecule, okay, exactly center here. So that molecule is get attracted by all the remaining molecules which are present here. Next, here what will happen? This is nothing but what? Basically, this is nothing but what? Free surface, correct, no? Free surface. This is nothing but what? Free surface. Okay. Next, this molecule, it is also getting attracted by all the sides, correct, no? But what is happening for this sphere of influence? That means for molecule B, what is going to happen basically? If we consider this as on horizontal level, below we are having maximum number of force which is acting in downward direction here, okay? And above also some molecules are there, but force of attraction is maximum, it is acting in downward direction. Now for this third sphere, what is going to happen? That means for C molecule, it is going to get attracted here, 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 here as well as here. That means here above, no doubt it is having its own sphere of influence, but no neighboring molecules are present over here, okay, at this point, at this part. So again here also what is going to happen? It is going to get net downward force. That means net downward force is acting in which direction? Downward direction. So what we had discussed, surface tension is the thing, but what? It is like the free surface of a liquid behaves as stretched elastic membrane. Right now? Clear? So this sphere of influence, that means this last sphere of influence, it is also having net downward force. Correct, no? And definition of surface tension, what we had discussed, it tends to have minimum surface area. That means all the molecules, they want to come down, and surface area for this free surface area for a liquid container, it stretches as, or it acts as stretched elastic membrane. Clear? So it tends to have minimum surface area, as well as one more thing, it acts as stretched elastic membrane. Clear? So this is a simple explanation of surface tension on the basis of what? Molecular theory. Clear? So next we are going to discuss about what do we know as surface energy. Listen, what do we know as surface energy? Let us consider a same container. Okay, and until this level we have what? Liquid. Clear? Until this level we have liquid. Okay, below this level completely we have liquid. Okay, right. Next, if I want to increase this length, that means what we are going to do? First of all, we have taken a vessel which is filled with water. If we assume, if this complete wall of this complete vessel, if it is shifting right side, or the cross-sectional area of this complete vessel is going to get increased, or this width is going to increase, so what will happen? This water level, it will come down. Correct, no? That means water level will come down, as well as one more thing, what will happen? The earlier molecules what were present over here, these will come to surface. Correct? Are you getting this point? Initially we had considered a vessel, okay, and which is having some cross-sectional area A, let us suppose. If I want to increase this cross-sectional area to double, that means we are going to increase cross-sectional area. You can understand in that manner, or we are increasing this a base, that means from this part, this point, we are going to increase means what is going to happen basically, water level will come down first of all. Water level is coming down, and one more thing what is going to happen over there means the molecules which were present earlier below this free surface, those materials will try to come above, or we can tell it as the molecules which are below the free surface, that means this is nothing but what? Free surface, correct? No? Free surface. So molecules which were present just below the free surface, those molecules try to come at the free surface. Are you getting this point? So if they are coming to the free surface means some sort of energy should be there. They should have to possess some sort of energy, correct? No? From that energy itself, they are coming to free surface. So the energy which is stored in the molecules, that energy is nothing but what? Surface energy. Clear? So earlier we had considered a vessel like this, okay, which is filled with the liquid, and later what we were doing, we are just increasing this complete basement area or cross-sectional area, we are increasing like that, you can just think of it, okay. Then what will happen? Water level will come down, obviously, and these molecules which were below the free surface, these molecules will come to free surface. The molecules which are present over here, these molecules, some molecules will try to come to free surface, and some will achieve also. They will come to free surface. So, what we are going to discuss here, first of all, the energy possessed by the molecule, that is nothing but what? Surface energy. Clear? And surface energy, it is given by, clear? Surface energy is given by the potential energy which is stored in that molecules per unit area. Yeah? So potential energy which is stored inside the molecule per unit area is nothing but what? Surface energy. Basically surface energy is nothing but what? Potential energy. But what should be the area value? Unity value. That means area should be equal to 1 meter square, means then what is going to happen? Surface energy is nothing but equivalent to potential energy which is stored in the molecules. Clear? So if I want to write SI unit means what is the SI unit for potential energy? SI unit for surface energy, yes, it is equal to potential energy. SI unit for potential energy, what is that? Yes, SI unit for potential energy. Yes, anyone? That is nothing but what? Yes, very good. That is nothing but joules. Whole divided by area. Area. What is the SI unit for area? It is nothing but what? Meter square. Okay. So, what in total, if I want to write means what I can write? J m power minus 2. Okay. This is nothing but what? SI unit for surface energy. Okay. SI unit for surface energy. J m power minus 2. Clear? And one more thing. If we want to calculate dimensional formula, clear? What are the dimensions of surface energy? If they ask what are the dimensions of surface energy, or write the formula for dimensional, write the formula or write the dimensional formula for surface energy. If they ask in this manner means how we are going to calculate? Can you help me to find dimensional formula? Dimensional formula. Listen. First of all, potential energy. You can choose any equation for energy, kinetic energy, okay, like that. Because energy basically they will be having same dimensions. Okay. So we are familiar with half mv square, which is nothing but what? Kinetic energy. Just for dimensional, to calculate dimensions, we are going to use that. Half m means that is nothing but mass, capital M. Okay. V square. V is nothing but what? Velocity. Velocity means displacement covered or displacement made in unit time. L t power minus 1 or L by t. mv square. Basically half mv square, but half is dimensionless. Okay. Next, area. Area L square area. Clear? So dimensional formula, how I can write? Dimensions of S is equal to, okay? Dimensions of S is equal to m L square L square. Listen, here L square, here L square will get cancelled. So what is it meant? M L term vanished, t power minus 2. Minus 1 whole power 2 it is. 2 is for both L as well as t power minus 1. But for L square it got cancelled here. But t power minus 1 whole power square is remaining. Clear? So dimensional formula for surface energy S is equal to m t power minus 2. Clear? Dimensional formula for surface energy is equal to m t power minus 2, or dimensions of surface energy is nothing but 1 in mass minus 2 in time. Clear? 1 in mass and minus 2 in time. Clear? Shall I erase the board? Clear? So next, here we are going to consider a vessel. Okay, completely. Okay, this complete vessel is filled with what? Liquid. Okay, and let us little bit will take it above. Okay, that means this will act as what? Free surface. Okay, and on this free surface we are imagining a line. Okay, which we are going to name it as X and Y. Clear? Below completely we have what? Liquid. Now on this imaginary line XY, on the surface forces will be acting in this manner. So if this distance is L, clear? Then surface tension T can be defined as F by L, where F is nothing but what? Tangential force. That means here on the free surface, whatever the molecules are having here, these molecules tries to stretch. That means on this imaginary line, okay, the molecule which is present over here, they will try to stretch here also as well as here also. That means here if it is stretching means the molecule which are remaining over there, they will also contribute their energy and they will also help to stretch it. And in the same manner it is going to happen. And forces are perpendicular to this imaginary line. Okay, like this. These forces are perpendicular for this imaginary line. All the forces. Okay. So then surface tension can be defined as F by L, where F is nothing but what? Tangential force present between these molecules. Okay, and the force, how it is acting? Perpendicular for this imaginary line XY. Clear? So surface tension can also be defined as, what is that? It is a tangential force applied, the tangential force which has been applied by the molecules perpendicular for this imaginary lines for per unit length. Okay, this L, if it is unity 1 means, then P is equal to F. Clear? And next step we are going to derive about what is the relation between surface tension as well as surface energy. Clear? Shall I erase this part? relation between surface tension and surface energy. So for this we are going to consider a loop like this. Okay, let us name this loop as A, B, C, D, and this side CD is movable. Okay, it can move. Okay, otherwise you can choose A, B, C, D, B, C is movable, something of that. Okay, but this side is completely movable. So according to surface tension definition, we had discussed that T basically surface tension T is nothing but what? F by L, where L is nothing but this length. Okay, and let this length be x or dx. Okay? So we know that T is equal to F by L. So if I calculate F means what we are going to get? T into L basically, correct now? Or listen, it is like a loop, okay, a rectangular loop we had considered, and this complete loop we are going to dip it in a water solution. I hope you might have observed this in your school days. When you were small kids, you will be going to use in that phase one liquid solution will be there, and something of this shape you are going to see like this. Okay, a tube will be present over here. From this part you will be dipping in that solution. Okay, can you able to see this like this? Here one tube will be there. From this you will be blowing air, but before blowing air, this complete part you will be dipping it in the soap solution. And once if you dip it in soap solution means here one soap film will come. Okay, small layer of that soap solution. And when you blow here, you are going to get what? Bubbles. Correct now? Have you remembered? So in the same manner, you can analogy with that. This is nothing but what? A rectangular loop. And this rectangular loop in a liquid solution, we dip and we remove. And when we do so, here one complete film will be there. And what is going to happen? This side CD, it tries to move this side CD, or the CD part will try to come here. Why it is so? Due to definition of surface tension. It tends to have minimum surface area. Clear? That means any liquid solution will tend to have, it is having the interest to create minimum surface area. Okay, on the basis of molecular theory also, this thing only we had discussed. All the molecules tries to come down means what is going to happen completely? At the top, it tends to have minimum surface area, as well as it acts as stretched elastic membrane. Clear? So here, this film is having two faces. That means if you dip it and see, means one is this side and one more will be back side one actually. So F is equal to T times of 2L. Clear? And if we want to bring this complete part CD to the original position or right side position by displacing it by distance x, means we are going to do some sort of work on that. Correct no? So what is basically work? Work is nothing but what? Force into displacement. Displacement is nothing but dx. Okay? Force is nothing but we have here. So work is nothing but W is equal to force is nothing but 2TL into x. Clear? So this work done, that means W is equal to 2TLx. This work done is stored in the form of potential energy in the molecules. We had discussed now when we were discussing about surface energy. all the molecules tries to come to surface area. But you should have to remember, whenever they are coming to surface, they will be having some sort of energy. That energy is nothing but what? Potential energy. Here what is going to happen? Here we have work done 2TL into x. If it is doing this much amount of work done, means earlier this much amount of energy it should have, then only it can do that. If you want to do some work, means you should have to gain that complete energy by eating good calorie foods. Apart from eating good calorie foods or with good lunch or dinner, you should have to gain that calorie, then only you can do the work. In the same manner, here some work should be done, means earlier this amount of work done should be stored in the form of potential energy. So what we are going to discuss basically, surface energy, S is equal to what? Basically surface energy, what we had discussed, surface energy is nothing but what? Work done per unit area, okay? Or how we had written that, potential energy per unit area. Here this work done is nothing but what? Stored in the form of potential energy. So if this amount is stored in the form of potential energy, means S is equal to what we can write, P in the place of P, 2TLX whole divided by. What about area? Listen, here if you dip it and see it, means one will be front view, okay, one more will be rear view. So area is nothing but what? This complete L, okay, and what is that? Here we have L. If I consider this as a rectangle, square loop, means let us assume. So this side will be L, and only for a small distance, if it is moving for x, means square loop means all the four sides will be same, L. From here, if it is moving up to here, means what will be the area? L into x, okay, special case, L into x. So what is going to happen? This is for Lx for one-sided, that means for rear-sided. Here I had drawn dotted line. But due to rear side, what will happen? Lx plus Lx, which is nothing but what? 2 times of Lx. So 2Lx, 2Lx will get cancelled. So what is remaining? S is equal to, S common, what is remaining? S is equal to T. That means surface energy is numerically equal to surface tension. Clear? Got the point? Or surface tension is numerically equal to surface energy. Got the point? So how we had derived? We had taken a rectangular loop first of all. Next, for that rectangular loop, what we did? We dipped in a solution and we removed. Clear? And then we told that this part is movable completely, and after that we had calculated from T is equal to F by L, we calculated F value, then we calculated work done value, then finally we had substituted in surface energy, that is nothing but S is equal to potential energy per unit area. But this work done is stored in the form of potential energy in molecules. Clear? So keep studying. Again we are going to meet it in our next class. Clear? Thank you.